From across the globe, from the centre of aerospace, and now to you.
Thank you for downloading the Aero Society podcast from the Royal Aeronautical Society.
A very good afternoon, everyone. Welcome to this Royal Aeronautical Society Heathrow branch webinar. My name is William Lee, and I am the Honorary Secretary of the branch and the moderator for today's session. Joining me today is our speaker, Mike Durham, the Chief Technical Officer of Hybrid Air Vehicles Limited, and our branch chairman, Peter Fryer, who will be hosting today's webinar. Before I hand over to Peter, there are a few housekeeping points I would like to clear out the way. First of all, please feel free to share your thoughts about today's event on social media channels such as Twitter by @RAESLHR and use the hashtag RAESLHR events to interact with us. Secondly, if you require a CPD certificate of attendance for your own initial or continuing professional development record, please use the Q&A panel now to inform us your name, and we will send this to you after event. Your microphone is on mute, but throughout the webinar, we do encourage you to use the Q&A panel to raise any questions that you may have, and you can also interact with us by clicking the thumbs up or like button next to each questions that are being published. Finally, I would like to make you aware that today's session is being recorded and will be made available via our podcast and YouTube channel post-event. So without further ado, let me hand over the floor play to Peter.
Thank you, William. Great introduction from Air Chief Marshal Sir Brian Burridge, the CEO of the Royal Aeronautical Society, for his video message. Hello, I'm Pete Fryer, the Chairman of the London Heathrow branch of the Aeronautical Society. I'm exceptionally pleased this lunchtime to be able to welcome all of our viewers to the 5th of this season's branch lectures presented as webinars. As you will all be aware, for the earlier lectures this season, I was unable to act as the moderator or chairman due to technical difficulties with the Aeronautical Society's Microsoft Teams license. For November's lecture, our third lecture, that was resolved and I was able to greet you personally to this season's lectures. I think we're probably going to continue sharing the role as chair between Anna, the vice chair, and myself into this year. It's now well into the Christmas season. So I'm going to take this opportunity in wishing you all my personal very best wishes and the best wishes of the branch committee. Thank you very much for giving up your valuable time to be delegates at today's event at lunchtime. I also want to check that you are in good health. I do hope that you are all keeping well through the upheaval caused by this treacherous virus. I have previously explained that during this year's virtual Farnborough International Trade Show, the UK government made important announcements concerning the setting of new national strategies in the area of a robust and strengthened green and sustainable future for the aerospace industry by promoting the recovery of our industry from the COVID-19 disaster, by changing the environmental footprint of the aerospace sector, by altering the face of aerospace development and operations by making the United Kingdom a world leader in sustainable technologies. Today's lecture follows this strategy, and our branch will be playing its part in the initiative by placing the additional emphasis on briefing you all on the way forward through focusing on the new future in this year's lecture programme. Congratulations to our very active branch committee member Chris Pocock for securing the services of Mike Durham the Chief Technical Officer of Hybrid Air Vehicles, to deliver his lecture Airlander 10, A Future of Zero Emissions Aviation. As a former student of the Cranfield University College of Aeronautics, the historic airship development site at Cardington Airfield, a close neighbour to Cranfield, has long been a familiar curiosity to me, both from the road driving past the giant airship sheds or hangars, as a student overflying the site in the exclusive Cranfield Flying Laboratory aircraft, and as a pilot transiting by navigating using the giant buildings as obvious waypoint landmarks. It is therefore an extremely exciting prospect for me to host today's lecture from the last airship OEM, using the site before its ultimate demise. Hybrid Air Vehicles is the company behind Airlander, the world's first hybrid aircraft and the first future of zero-emission aviation. The first production Highlander 10 aircraft will deliver up to 90% reduction in emissions compared to other aircraft in its various roles. Airlander provides a clear pathway to practical zero-emission flight by 2030. The vehicle will deliver a wide variety of benefits within regional mobility, remote logistics, luxury experimental travel, and communication and surveillance applications. In this lecture, HAV's Chief Technical Officer Mike Durham will provide insights into the HAV journey so far and the HAV pathway forward to bring Airlander to market by 2024. The presentation will include use cases of the aircraft and look at the improved passenger experience with less noise, more space, more windows, and no requirement for a pressurised cabin. Mike will also touch on the scale up of the Airlander technology for an Airlander 50 and an Airlander 200 in the future. The environment and reducing CO2 emissions is an important topic in aviation today, with the aviation industry forecast to emit 24% of the world's CO2 by 2050. Mike will delve into the topic of emissions reductions, looking at the Airlander's environmental credentials, their ongoing work with Collins Aerospace and the University of Nottingham to develop electric engines, and their planned use of hydrogen to enable zero-emission flight. Mike has over 30 years' experience developing lighter-than-air technologies, having graduated from Loughborough University with a degree in aeronautical engineering. He started his career with British Aerospace and during the following years became involved with structural design for the Hubble Space Telescope, Skynet 4, and fatigue analysis on the Tornado air defence variant and the Harrier aircraft. Following a brief period in the design of helicopter and rocket motor systems, he joined Roger Monk, the inventor and former technical director of the team, in 1988, where his talent and passion for lighter-than-air vehicles was quickly recognised. Under Roger's leadership, Mike took on the responsibilities of lead designer for multiple military and civil projects, later becoming a Civil Aviation Authority and EASA approved signatory and company design authority. Mike became Chief Engineer of the Hybrid Air Vehicles Limited at its inception and Technical Director in 2010. He leads the technical development of all of HAV's products. To all of our audience today, if you have any questions for Mike, I encourage you to pose them through the Q&A window, which can be opened from the question mark button. I will now pass over to Mike Durham, who, following his earlier short video, will present his lecture Airlander 10, A Future of Zero Emissions Aviation. Mike, welcome to the Royal Aeronautical Society's London Heathrow branch. Over to you.
Thank you for the introduction, Peter, and thank you to Royal Aeronautical Society Heathrow for the opportunity for me to blather on for a short while on the subject of Airlander and our path forward. But also we'll take a little look at the how we got here. So moving straight in, the good news is I don't need to worry about my CV or anything like that. Peter provided that one very nicely. So who are hybrid air vehicles? I mean, we're a small business. We're about 65 employees at the moment, with significant plans for expansion as we lead into 2021. Although hybrid air vehicles was established back in 2007, as Peter said, we sort of heritage all the way back 30, 40 years for some of our employees, back under previous airship businesses in the UK. We're currently based in 2 facilities, one near the centre of Bedford, which is our design office, and we have a modest-sized production facility just down the road from here. We're not down at the hangars anymore at Cardington, although I personally have high hopes that we might return there one day just to finish Airlander 10 off, but that's for the future. We hold a full aircraft design DOA approval under EASA, which has been very valuable over the last few years. It's enabled us to go off and do our flight test program with the prototype aircraft. And more recently, we now have a production organisation approval under CAA, which allows us to do some of the R&D work that we've been undertaking over the last 2 or 3 years. Since retiring the previous aircraft, we've really spent the last couple of years focused on the path forward and into production for Airlander. That first aircraft, which is in the picture there, it's the only sort of full-size hybrid air vehicle of any form to have flown. 1 or 2 businesses out there have done tethered flights and have done flights of subscale demonstrators, but the money, it's not the monetary value, the technical value that we have had out of that prototype aircraft and the flying we did with it has been huge. It's been immensely valuable to us. So we took that through to a sort of TRL 7 standard, and now we're early in the new year, we'll be delving into the production program, which should see us in the air early in 2024 and hopefully type certificated in 2025, allowing us to move forward into selling aircraft to the world. So, as I say, we've built and flown a full-size Airlander. I'm really proud to be part of probably the most experienced airship design and test team in the world. I've managed to cling on to a whole pile of old fogies here, and they do a tremendous job of colouring the enthusiasm of all the youngsters we have here with sage stories of how it was done in the old days, and the youngsters always counter back with how it should be done these days. So there's a really good balance within our team of wise old hands and all of the current cutting edge technology that you really need to be an OEM today. The learning from flight and from ground operation of the prototype Airlander has been invaluable. We've done all of the standard sort of lessons learned type processes that one should do following the flight test program. We probably learnt as much on the ground as we learnt in flight, and that's really helped us. So the last 2.5 years or so, we've been completely focused on how you take all of the knowledge from that first aircraft, which, let's remember, 10 years ago was designed to fulfill a very, very specific role for the US Army. This was about high altitude, unmanned surveillance for multi-day missions. And you compromise your design, the flexibility of your design, if you focus in tightly on one particular operation. And that's what we did with the first aircraft. But we know where we compromised the design, and this last couple of years has been all about taking that knowledge, bringing it forward and making it into the aircraft that it needs to be, making sure that the landing systems are capable of doing a takeoff and landing every hour, every couple of hours, if that's what's required. Whereas on the old aircraft, the prototype, that landing system, really, it was just parasitic weight for most of the time. We were planning to fly anywhere from 10 to 20 days at a time. So you were only using that landing gear once every 10 days. And that drives you to a different set of design parameters. So evolving on from that niche market prototype aircraft into an aircraft that has capability across multiple different use cases and end users has been very important to us. For those of you who don't know what Airlander is, and obviously I'd be amazed if there's anybody out there who doesn't know what Airlander is, we effectively get about 3/4 of our lift from buoyant lift. We use helium inside the hull. It's a pressure stabilized structure, so there's no internal metallic or composite framework within the hull. It effectively keeps its shape due to pressure. In old money, about 4 inches water gauge, which is about 1/6 of a PSI. In new money, haven't got a clue. Unfortunately, I'm still very much an old money person. So 3/4 of our lift is buoyant lift, and we take the balance of that lift requirement from aerodynamic shaping of the hull. So you'll see our hull is wider than a conventional airship. It's like 2 or 3 airships flying in close formation effectively. That generates a sort of a blended wing shape, and you can get substantial aerodynamic lift off of that. The final piece, we obviously have the ability to vector our thrust from our 4 main engines. The 2 at the front, unlike on our prototype aircraft where we had ducts with vanes, for the production aircraft, we are now going to inboard engines with outboard open propellers. That enables us to vector the thrust quicker and more effectively, whilst at the rear we'll stick with our ducts and our turning vanes. So those three mechanisms for lift can all be played in. Of course, the key piece is that buoyant lift element, that 3/4. That's a substantial part of why we burn less fuel than other types of aircraft. We sort of get to stay up for free. We just need to push ourselves along. Whereas the rest of the world out there is having to keep itself up and push itself along using fuel. So we start off with a product that is low carbon production, typically compared to a fixed wing airplane. We're running at about 1/4 of the carbon production. And there are lots of ways of talking about those figures, but we tend to think of that as in terms of either seat kilometres or ton kilometres is the easiest way to think of those. I think as we move forward and we start our production program in the coming year, the good news for me is I feel we've got very few technical unknowns now. The new production aircraft, in many ways, it's very similar to the prototype. We learned what to do and what not to do on that aircraft. And we've also spent a lot more time working with potential customers to make sure that we had a solid set of key user requirements that we can develop the aircraft to. So, you know, in some modes we're carrying 10 tons of freight. In other modes, we might fly 5 days with a few tons of surveillance equipment on. The goal is to be certified for IFR flying and flight in known icing. And one of the happy side effects of the new landing gear system that we're putting on the production aircraft is waterborne operation. It's pretty straightforward to do, and we can broadly land in any muddy field you like. So our impact on the environment in terms of ground infrastructure is low as well. So what have we been doing this last couple of years? So pulling the knowledge out of the ground and flight test program, that's really helped us along. When the prototype aircraft left us nearly 3 years ago now, we had our flight simulation system. We have a flight deck simulator in the design office here, and that was being kept up to date with the flying aircraft. So after every flight, we would embody what we'd learned into that simulator, and we've kept that simulator evolving with the new production design and with the knowledge that comes from things like our wind tunnel testing. We've been working with Mercedes Grand Prix team over at Silverstone. We've borrowed their tunnel quite a few times. They constructed the most beautiful aerodynamic model of the new production aircraft. We went through 2 or 3 iterations of some of the features on that, got some really top draw aerodynamic data. We then went and put Flovi's paint on it and managed to muddy up the whole of their tunnel system. Took them several days to clean it down after us. So I apologise to MGP for that. But we learned a lot of good data, and that, along with the flight data that we took from the real aircraft, that's allowed us to help validate the CFD work that my flight sciences team have been doing. So there's a lot of good knowledge there. We're much more comfortable about the drag figures we're getting and the lift characteristics and where the lift is acting on the vehicle and so on. We've also been doing a lot of materials work. The prototype aircraft, most of the structures on it were either carbon composite or glass fibre composite, all of it pre-preg. But we had that coming in from about 4 or 5 suppliers, and we have multiple different types of carbon and glass and so forth. This time round, we're having one carbon system and one glass system, and we've been doing the initial material validation and properties work and developing the pre-preg out of autoclave processes that we need so that we can guarantee the quality of the data. So that's all been coming along. As I said, the simulator has been evolving as we go. We're just about to change to the new flight deck layout in that simulator, but we've been doing lots of takeoff and landing, free flight, you name it, we've tried it in the simulator. Very, very useful to us. And the other piece that's come along in the last year and a half, 2 years for us has been the need to have a really solid technology pathway forward. You know, it's great that we're 3/4 the carbon production of other airplanes. That's terrific, but it's not good enough for us. So the next steps are to go to what we call a hybrid electric version of Airlander. So the front 2 engines replaced with electric motors and fueled from probably a pressurised hydrogen storage system and PEM fuel cells. And on beyond that, potentially going to cryogenic hydrogen and going electric motors all around. So we have a pathway there that takes us through to somewhere around 2030 for an all-electric version of Airlander 10. And that technology, again, will then feed forward onto the later products that I'll give you a glimpse of later on in the briefing. So we've had a lot to do in the last 2 or 3 years, and we're now pretty much prepped up, ready. My programs team tell me that they have a plan. They know what we've got to do on day 1, month 1, year 1, and so forth. I hope they're right. I'm happy just to be the engineer in this. So as we move forward, we get that pathway, getting into the air in 24, getting the first lot of electric motors and hydrogen onto the aircraft for sort of 25, 26-ish, and then being all electric in 2030. I think the other piece we should bear in mind with Airlander, it potentially gives other areas of the aviation industry the ability to test fly their hardware earlier in a relatively benign product. We've done a lot of work with our aviation safety people over at EASA in terms of FHAs and SSAs and all of those lovely acronyms that my safety team like to throw at me every 5 minutes. And it's quite clear that our failure modes are more benign than most other fixed wing products. We also, we're flying in a sort of, if I generate 1.5 G on the aircraft, I'm starting to question the pilot. That's about as much as we can do. So the ability to take lab qualified type equipment, whether that be a prototype fuel cell or a prototype storage system or a prototype engine, we have all of those capabilities. So we're obviously open to working with the rest of the aviation industry in the UK to help them along as well. Let's fly some of your hardware early. Let's get you to altitude. Let's see how it performs. Let's try and push the TRLs earlier for the rest of UK industry. So where are we going to use Airlander? As Peter alluded to earlier, we've sort of got 4 main buckets that we're fishing in. The first one, flexible logistics. There's no doubt we're getting some traction now with some of the big next day delivery businesses and freight businesses around the world about how to move their products from one distribution centre to another. Airlander 10 is probably about the right size for that sort of thing. 10 tons of freight. Now, for 10 tons of freight, we need to land in a field next to the distribution centre and unload. We can do 5-6 tons of freight from the hover, if that, and that has some flexibility benefits. In the all kerosene aircraft, 3,500 kilometre range is easy enough for us. As we go to hybrid electric, that range comes down. That's just the power density challenge that we're going to have with electric propulsion. Most of the freight forwarding businesses we're talking to, their problem tends to be in that 400-500 kilometre range area. So, we think that Airlander hybrid electric is a good solution for them. And in just about every use case that we've analysed for that role, we're beyond a 90% CO2 saving. And that one is characterised in CO2 production per tonne kilometre of freight delivered. And we're doing that delivery relatively slowly compared to fixed wing airplanes. So, 100, 130 kilometres an hour, but it's still a lot faster than road. You're going direct A to B. So it has some benefits. So it'll be really interesting to see where the logistics market, which entity in the logistics market kicks in first and stumps up an order. The other place that we see real benefit for Airlander, communication surveillance. Our first product was effectively very kindly funded by the US Army. Thank you very much, US Army. Being able to buy that vehicle back and then test fly it here, we learn a lot more. Our relationship with the Army continues. We're still talking to them. We're talking to all sorts of different branches of the services over there. We have conversations underway in the UK with some elements of UK military as well. They see the opportunity here, the persistent surveillance, the being able to sit this over a place of interest, or even stood back 30 or 40 miles from a place of interest, and get the pattern of life data. This was always the big buzzword back in the LEMV days in 2010-12 when we were working with the US Army. By sitting this up there for 5 days, they can see patterns of life. They see where, trucks pull in at the side of the road for no apparent reason. They sit there for half an hour and then they drive off. They know that something may have happened there. They go send a team in to look for, improvised explosive devices and so on. So this pattern of life capability, hugely valuable, and we still see enthusiasm out of the military for it. For those types of role, you don't need to rack around the airspace at high speed. We can bring ourselves down to our loiter speed, somewhere around 30, 35 knots, 60 kilometres an hour, and we just sit there. We sip fuel at that. And even with the 4 kerosene engines on board, our endurance per tonne of freight it's about a 90% reduction in CO2 for that as well. The mobility one is something that's really come to light in the last year or so, with COVID coming in and all of this, and the desire to build back better. We really see an opportunity for Airlander as a mobility provider. We're not talking about the long range stuff. We're not about to start flying the Atlantic. Our focus is, you look at domestic air travel where you're flying maybe an hour, you might be in the air 50 minutes. So we've done some study work with, some UK, some European, and doing some American sites now, city pairs. And we look at the total end-to-end flight, end-to-end time. So I go on Google and I hit Liverpool city centre and it gives me a point on the map. And I then have to work out how much CO2 do we use for a person stood at that city centre. They've got to get to a train, maybe the train to an airport. There's then the taxiing around on the ground, the flight, and the same at the other end to get to Google's city centre definition of the other end of the journey. And we work through those and we see that fundamentally our CO2 reduction is dramatic compared to fixed wing. There is no doubt, we're not about to go and replace every 737 or every Airbus A320 that's out there. But we think there's a marketplace for our product at 200-300 kilometres range. It means you're on board for 2 to 3 hours rather than maybe 50 minutes. So we need to make it more spacious. We need to give people the ability to go and stand at a bar. But we want an environment that is more like a ferry or a first class train cabin. So, we say we cram 90 passengers and their luggage on, but actually there isn't an economy seat in the aircraft. It'll be, it's premium space or it's business class space. And we think people are potentially prepared to, for the same money, the same rough ticket cost, what you're paying is you're paying an extra hour or so in your life for flying a bit slower. On the other hand, you're flying lower, you've got a good view, you're in an unpressurized cabin. Typically, we're looking at flying 3,000 to 5,000 feet, something of that order. And we'll be doing those flights at 100, 120 kilometers an hour. But the real thing is you knock CO2 for 6 on this. You make huge reductions in CO2. And I think the market is out there for people to accept that it'll take them an hour or so longer to get there, but they will have done their bit for the planet on that journey. So we've got some of this data comes from our website, but we looked at some city pair examples. Liverpool to Belfast's a good one. You can see the sort of distances. We're operating Airlander off of water in both cases here, or as somebody pointed out to me, our takeoff region, it's water half the time and it's mud the other half time, but Airlander's pretty happy on either of those. And you can see we're an hour or so slower than the airplane. And remember, this is end-to-end journey time. This isn't the time you're in the air. This is all of the messing about at each end, the getting to the airport or the getting to the takeoff site. And you can see, we do really well on CO2 production compared to the aircraft. We're about the same as the ferry, which is the other route for getting between the two, but we do really well on time. So, we're not the universal panacea to air transport or travel, but we think we have a part to play in the mobility conversations that are going on. And it certainly seems that the government is beginning to engage with this as a strategy. If we move on from there, this was the sort of really sexy end of things that we started out looking at 2 or 3 years ago from a commercial standpoint. We've got 15 letters of intent in play with various parties around the world for experiential travel. Now, for most of us, and I include myself in this, this is unaffordable. This is luxury tourism at its highest. This is almost the airborne equivalent of hiring a super yacht in many respects, maybe one step down from that. But what we're looking at effectively is you take that same Airlander cabin, which is, broadly speaking, it's about the same floor area as an A320, something of that order. It's obviously unpressurized. You can see the windows here in this view. And we can take about 16 passengers plus 3 helpers, so 19 passenger accommodation. And we're giving them an ensuite cabin down the back, not shown in this view. We're giving them a nice seating area, a bar, dining space, and the ability to fly low and slow. So, again, you can go off and you can do a couple of day flight where one or two of our partners are looking at going to the North Pole, for instance. But remember, this cabin, it's a long way away from the engines. And my chief test pilot, Dave Burns, spent quite a bit of time whinging that when we turned our front engines to idle during test flying and we were doing performance stuff on the rear engines, he on the flight deck, he couldn't hear the rear engines running. So once you're in flight, a lot of these experiential travel ones and a lot of the point-to-point mobility stuff will be done on rear engines alone. And that means that effectively you're flying in near silence. There's no vibration down there. The things that vibrate, the engines, for want of a better word, they're all away, 150 foot away at the back of the hull. So you've got a lovely isolated, low vibration, low G cabin. We're affected differently when it comes to things like turbulence. We're a very long aircraft. We're flying quite slow. So by the time you've got a nasty spiky chunk of gust hit the front of the aircraft, it transitions down the aircraft over a period of time. And by the time that lumpy bit is moving down, there's another calmer piece coming in. So that the whole sort of in my simple world at least, this is your spot, I'm not an aerodynamicist, the turbulence sort of averages out. So I think the experiential travel market, obviously, it's taken a huge hit with COVID, but we're still talking to the people who raised LOIs with us back this time last year. They still want to do this, but we've got to build back to it. So we hope that they're going to come back online over the coming year. So where do we go to from all of that sort of nice backward-looking stuff and the markets and so on? Well, in the next 5 years, we need a bit of help from technology. We've got some developmental work to do to take us to the hybrid electric version of this aircraft. And fundamentally, I've broken that into 2 slides. The first one, you need motors. We need large-scale electric motors to be able to push our aircraft along, or pull it along, depending on which way you look at it. And we're doing an ATI-supported, grant-supported program with Collins Aerospace and University of Nottingham to build the prototype 500 kilowatt motors. And those will be the motors that will go on the front propulsors. You can see in the left-hand picture there, just under the R of Airlander. The motor sits inboard in what we call the pylon, drives through a transmission shaft out round a 90-degree gearbox and into the propeller. That's the kerosene one. We can throw all of that stuff away, and we put our electric motor out on the end of the pylon and drive straight into the back of the propeller. And the guys at Collins and Nottingham, we're getting really close now. We start building prototype hardware. We'll be testing that on dyno rigs midway through 21, and later in 21, we actually go out onto a full-blown propeller test stand. We're going to be donating some propellers off of our prototype aircraft to get some real thrust data out of these electric motors, to really get the whole soup to nuts sort of story of efficiency all the way from the power supply through to how many pounds of thrust are we generating. So that project is ongoing, and I would see that moving on into a sort of production version of the motor controller thing for 22, 23. Now, it's all very well having electric motors, but you do need quite a lot of energy to pump into those motors. And we started off probably 4 or 5 years ago. We were looking at battery technology. It's safe to say we do look at solar technology as well, but we kind of want to fly this aircraft at night, and we kind of want to be able to fly it in any direction we want to. So although we've got a lot of real estate space up on the top of this hull, and we've had schemes done showing how we can populate the top of the hull with solar panels, and how you route that power down, and how you deal with things like lightning strike and all of that sort of stuff. The real reality is the solar option it's a pretty long way away from being a viable thing for us for most of our roles. It does have some opportunity when you're looking at some of the loitering, some of the surveillance type roles, because the amount of power you need to push us along at sort of 30, 35 knots is much lower. So we keep monitoring solar, and we keep monitoring battery, but the real way forward for us is going to be hydrogen fuel cells. It gives you the power density, it's 3 or 4 times better than batteries. It's still only 6 or 7 times worse than kerosene. So this is why you see for our hybrid electric product, the range has come down quite significantly. I think we're using fairly conservative numbers within our design process, but I don't want to oversell this one. But we're looking at a power storage system that can have 6,000 to 9,000 kilowatt hours of energy. That's some quite big storage vessels. The good news is, of course, we've got a load of internal space within our hull where we can put those storage vessels. So we're not having to compromise the passenger space that you might do on a conventional shaped airplane, where you can't do the pressure levels that you need in a wing. So you've got to bring all that fuel into the fuselage. We're also studying the cryogenic storage of hydrogen, and that may well be an avenue that we end up in. So that's all ongoing at the moment. And again, this is all about trying to make sure that we are integrated with the rest of the aviation world. We're all out there trying to make electric work, trying to make carbon reduction work, and we want to be a core part of that. So that technology, that's the technology we need to help, to get some help with along the next 4 or 5 years, so that we can go to our hybrid electric one in sort of 2025. And that all sounds quite exciting. It's certainly going to take up the next 4, 5, 6 years of my life, which is fine. I'm up for the challenge there. But where do we go from there? A 320-foot long aircraft, 10 tons of freight, big distances, it's not enough. We talk to lots of potential customers out there. They want bigger payloads, they want further. They'd ideally like a little bit faster, but strangely, the speed thing seems to be less of a problem, particularly in the freight market. So where we move to next, really easy. Let's just press the scale up button a bit. Let's go to something that can take 50 to 60 tons of freight. We're now talking about being able to move 6 20-foot ISO containers, being able to deliver 2 or 3 of those at a time from the hover or land on, move 6 away. This aircraft, you're now getting up into propulsors that need to be just under 2 megawatts a corner. So again, you can go electric. That brings that 4,000 nautical mile range number down quite significantly. But we're now talking, early 2030s for this. Fuel cell technology will have moved on. The efficiencies of that will have moved on. So, I'm hopeful we're still looking at an aircraft that will be good for 1,000+ nautical mile range, even on electric. So we're definitely seeing some enthusiasm there. You could use this aircraft and go and stick enough passenger space on for a couple of hundred passengers if you wanted to. This one also flies a bit faster. We've moved up from the sort of 130 kilometres an hour. Now we're up there in the 180 kilometres an hour, ripping along, as I like to think. I mean, I started my career in rocketry and fast jets, and it's taken me nearly 30 years to adjust to the fact that 180 kilometres an hour is really going some. So that's an opportunity there, and we've got some plans around that. We've done a lot of initial study work, and we'll start that program up in a couple of years' time to run staggered behind the Airlander 10. And of course, it's not really big enough. I'd like to go out, with a real tour de force. So late 2030s, let's go to 200 tons of freight. Let's start to produce almost a ship in the sky. You're now looking at a payload module that's got sort of roll-on, roll-off loading capability, ramps at each end, and you're getting on for a sort of small-sized warehouse in the air. And again, because of the scale effects you get into, you start to push up the speed a little bit more. This 200 kilometres an hour, that's probably about the top end for lighter than air. I take great pleasure in looking at PowerPoint slides that various other airship companies produce that talk to 300 and 400 kilometres an hour. And they obviously have a different physics notebook to me, because I think topping out somewhere around 200 is the logical place. But you're now in a transoceanic capability aircraft. So, the future's, there's a pathway to the future there. I've spent the last 30 years effectively in an industry that is considered disruptive and therefore tends to get discounted a lot. But I feel, with the advent of COVID and the need to sort our act out on carbon production, it feels like lighter than air's time may be coming again. Not for all modes of transport, but there are some significant areas in the aerospace world that I think we can help in. So just to summarise, we built one 300-foot long, flew okay. The technology is scalable. We're not trying to bend or challenge physics in any way. We understand the scaling rules on this stuff. The last couple of years, we've managed to put together a strong supply chain. We've got a production version baselined. We've been flying that in the simulator, so we understand where we're starting from. And we've got a pile of LOIs in train. We need to convert those in early 21 into contracts, orders, and we can start the next chapter of Airlander. But we are committed at HAV. In the next 5 years, we're going to deliver Airlander 10 to market. We're going to develop the hybrid electric version of that and start our contribution towards getting to zero carbon. And we stand ready to help the rest of aerospace with some of this early risk reduction flight type stuff that we can help do moving forward. So there you have it, Airlander in a nutshell, really. And I think at this point I can pass back to Peter, who's going to corral some questions for us.
Thanks, Mike. I really enjoyed that. That was an awful lot of information to take in. One of the things you said there in your summary that I'm going to just quickly gather on, most people could see the airship industry as a thing of the past. You used the word the airship industry is disruptive. I personally kind of almost thought that myself, but I'd never used those words. That was quite interesting to hear you say. Another point I've got was that it was good to see the message of the new part you're going to play in the currently fashionable urban air mobility sphere, joining city centre pairs. I think back to my university time when the fairy Rotterdam was seen as a thing of the future, where cities like Southampton had a Twyford Moors city centre heliport operating as a fairy Rotterdam urban air mobility centre, if you like. The London area had the Westland heliport. Interesting to see that that's now your new message. I'd like that. I was recently looking at a website of a tour operator that was offering Arctic and Antarctic holidays. Again, I saw that as the rich man's yacht of the future. That's kind of the messages I took in that were really quite key to me today. Anyway, I'm going to move on and deal with the questions now. Let's take them one by one. You've told us where you currently are located. Are you thinking of moving away from the Bedford area, or are you going to stay in the Bedford area?
So Hybrid Air Vehicles is committed to remaining in the Bedford area. We have a long lease on our design offices here. The thing that I can't guarantee is where we're going to end up with our production facility. There is no doubt that over the last 4 or 5 years, Cardington has it's not been quite closed down, but it's getting very tight to operate out of. If I look back at our flight test program in 2016-17, we had quite a tight windrows to operate from for our flight test work there, mostly because we had quite a tight wind limit as well. So not only did we need relatively low winds because we were trying to do some clinical flight test, but we also needed the winds from the right direction. And Cardington is starting to become really quite difficult from that standpoint. But there's no doubt, I'd really like our production facility to be within a mile of our design office, because it keeps the designers off the road. It keeps everybody closer together. But I really can't say at the moment where that production facility is going to be. We're looking at a number of options. We have land agents in play and so forth. So watch our website on that one.
Great, thanks for that. The next area down into two halves. When you first started, you had big American players as your partners. Was it Westinghouse, General Electric, Lockheed? I can't really remember now, but are those partners still with you, or are they a thing of the past?
So when I started in '88, Airship Industries, as it was then, was partnered by Westinghouse because we were doing a US Navy large airship program. And that's long gone. That finished back in the mid-90s. We teamed with Northrop Grumman for the LEMV program, the US Army one, because there was no way the US Army was about to let a $500 million program to a tiny little British business. Remember, at that point in time, when we won that contract, there were 12 of us in a porter cabin at Cardington. We needed a big brother, and we selected Northrop Grumman to be our big brother in it. I think if you talk to Northrop Grumman, you'd find that they said they selected us, but we put Northrop in as the prime for the LEMV program. at the end of that programme, the sequestration in 2013, Northrop Grumman went their way, we went our way. The good news was that, having had a lawyer as a CEO back at that time, we negotiated our IP rights very, very carefully. And by the time we got to the end of 2013, all of the IP for the aircraft was vested back into hybrid air vehicles. So no, we have no relationship with Northrop Grumman at this time. Lockheed Martin obviously is the competition to some extent, and for us, we're delighted to have players of that like out there supporting the concept of.
I'm going to go to the other half of that now, partners of the future. We had Val Mithnikov from Zero Avia at Cranfield, just down the road from you, talking to us about his 250 kilowatt leading to a 500 kilowatt power train using electric motors with hydrogen fuel cells. Do you have future partners in mind, or is that something you're commercially going to sit on for the time being?
Yes and yes. We're out talking to a lot of different entities at the moment. We're trying to shape the whole of the hybrid electric project going forward. Obviously, we have our partnerships with Collins and UON. We would like to continue those on beyond the EHAV1 program that we're currently on. But we are talking to a whole variety of potential partners, particularly with regard to fuel cell systems and hydrogen storage and all of that sort of stuff. So yeah, again, watch the website.
Let me just quickly check. Let's go back to the list of questions. We're all aware of the early landing incident to Airlander. Could you tell us more about that problem, how it was resolved, and reassure us that safety of ground handling, such as large light vehicles like this, are now in hand? Yes,
so I don't think there was ever a publicly issued statement on what went on there. It was investigated by CAA. We understand why it happened. It came down to a malfunction in a piece of ground equipment, of all things. And to some extent, we got bitten by the fact that we were flying on a low wind day. We had some solar gain on the hull as we pulled in over the airfield. And we were fighting to force the aircraft down to the ground. Now, will we be able to avoid that in future? Hell yes, we will. We've spent a lot of time working through the why this happened and the how it happened. Frustrates me completely that had we been in the hover about another 50 or 60 feet further up, it would have looked like a perfect landing. The aircraft was coming out of its pitch down attitude as it touched the ground. But it's one of those things. We learned so much from that event. And to some extent, that event took us towards the new landing gear systems that are going to be on the production aircraft. It was a wake-up call for how the sort of long sausage type landing system that we had on the prototype aircraft, it didn't really give us the ground clearances that we wanted, and the new design of system, it's definitely been informed by that event. But it was a terribly slow speed accident, it has to be said, and both pilots just stepped out of it and helped with the recovery of the aircraft. So it could have been a lot worse.
For that, I'm sure lots of people are interested in that one. Following several airship disasters between the wars, the aerospace industries avoided hydrogen on safety grounds. I presume that the lifting cells are currently filled with helium. Yes, I saw that in your slides. With the current drive to power commercial aircraft with hydrogen, will the lifting gas be changed to hydrogen in the future?
So I must admit, having spent the best part of 25 years in lighter than air, never mentioning the word hydrogen. There's another H word out there as well, that clip at Lakehurst has followed the lighter than air business from the 1930s all the way through. I now find myself being a huge enthusiast of hydrogen, but only as a fuel, not as a lift gas. We have no intention of swapping out that nice inert helium for hydrogen as a lift gas. hydrogen as a fuel, it shows actually to be, it can be potentially safer than kerosenes and safer than petrol and so forth. So I have become quite a convert to hydrogen, but definitely not putting it in the hull.
Thanks for that. The second half of that question I'm going to ignore because you've already answered elsewhere, but let me move on. Will the company be the sole operator flying the craft? Well, I think the answer to that is you're the OEM. Or will the aircraft be sold to new operators to offer their own services?
So I think the entry into service program that we're starting next year, effectively that will build the first 3 aircraft, and those aircraft will all be used as part of the flight test program. We've got something like 2,000 flight hours to put in to get, we believe, to get ourselves to our type certificate. Those aircraft will then be refurbished and will be sold on to early customers. We've signed a teaming agreement with 2XL, and 2XL will be our partners in crime for the early operation for some of those early customers. So although we'll be the OEM, we of course will have a vested interest in safe operation of the early Airlanders, building all of the things you need to build into a program that's going to hopefully deliver something in the order of 12 aircraft a year. There's a lot of pilots need to be trained on that. So between ourselves and 2XL, we'll be able to offer, either we can sell an aircraft to an end user, or we can provide effectively an end user owned but operated by 2XL/HAV. So we'll stay closely involved with all of our customers, at least in the early years.
As you know, Chris Pocock was key in getting you to come and talk to us today. And I've got a question here from Chris that has 4 supporters, so it's five users of the same question. Hello, Mike. Regards from Chris. If the castering ground cradle is no longer required because of the redesigned landing gear, is that because the pads will now be sucked down? And why 2 sets of rear pads in the redesign?
So all sorts of fascinating bits in that question. So the castering ground cradle was effectively our temporary landing gear that was tucked in under the back of the aircraft when we were on the mast, when we were engine shut down and so on. Its primary function was to stop us wearing the bottoms out of the landing gear. And that was a lot to do with the sausage type design of the landing gear that we had on the prototype aircraft. That piece of ground handling equipment, it was big, bulky, ugly, and you know, it wasn't hard to get in place, but it was just another piece of ground equipment. So what we've moved on to now is, with the new landing gear system, we can go to a higher level of reinforcements on the bottoms of the studs. I call them rugby studs. The bottoms of those studs will have a high wear resistant surface on them, and that allows us to not have to have a castering ground cradle under the back of the aircraft when it's moored on the ground. The reason we end up with 6 legs, fundamentally, when we did our functional hazard analysis and so on, it became apparent that actually it's really quite handy having 4 main landing gear there. And the bottoms of those studs, those rugby studs, they do need replacing. They wear like a tyre, so to speak. And what we have the ability to do is, with pairs at the back, we have our aircraft on the mast at the front, so we're supported on the front. We can retract our front legs to sort of lift a corner and replace the shoe underneath, the faying surface underneath. And at the back, we can sit on the mast with 3 of them inflated, deflate the other one, replace it. So it's part of a maintenance strategy. But also, of course, you've got to look at the loads during takeoff. We take off at about 6 or 7 tons heavy, so we need aerodynamic lift for takeoff. And as you rotate nose up and the lift starts going to the front of the aircraft, it definitely helps to have 4 main landing gear at the back there to support the weight of the aircraft as it rotates and climbs into flight.
Thank you. Have you been in touch, or do you envisage any specific airports for operating flights? Airport compatibility planning being developed?
So, in the main, one of our strong points is we don't potentially need an airport. You know, a lot of the city pair stuff that have been analysing for our sales team and our marketing team, a lot of those city pairs, it's actually more convenient for us to operate off of water. And, you know, we're not hugely suited to operating from a conventional airfield. You know, conventional airfields tend to be littered with sticky up pointy things, you know, taxi lights and runway signs and that sort of stuff. We don't really need any of that. So I'd rather be operating either from a greenfield site or a blue site, you know, from water. So it's not to say we can't operate from airfields. If I go back to when I joined the first airship business, back in the 80s, they did a shuttle service from Charles de Gaulle to Orly in Paris. They were shuttling backwards and forwards between those two sites with a Skyship 500 and moving passengers backwards and forwards. And that integrated in fine with air traffic control and so forth at those two major international airports. So I'm not too worried about, you know, we can operate from airfields, but at the moment, I think it's simpler and easier for us not to.
Got a question here from Houston, Texas. It's a chap called George Abbey Jr. Thank you for the opportunity to join you all. My question is, are you looking at all in the concept to decouple the transportation module from its load, or in plain English, to create a plane that transports interchangeable cargo capsules? Further, to have those interchangeable capsules integrated into the new UK rail system, for example, the Northern Railhouse region, including Manchester, Newcastle, Leeds, Sheffield, etc. Thanks for that one, George. Over to you.
So there's no doubt this idea comes up quite often, and it's got great parallels back in the world of I think it was Jerry Anderson and Thunderbirds back in the 60s and 70s when I grew up, where Thunderbird 2 had a pod that you could deliver and you picked the relevant one for the mission. The challenge with that is, as an aviation business, we take responsibility, or the customer would take responsibility for the carrying of that piece of hardware. And if that piece of hardware has been kicking around on the back of a train or has been in road transport and so on, you've got to be confident that it hasn't been damaged in some way that would result in it separating from our aircraft. So there are definitely some challenges in terms of creating some new form of intermodal box that could be used for aerospace and could also be used for road and train. I mean, I think the other thing to bear in mind, of course, is that when you look at the loads and so on, typically when you build stuff for road freight, there's quite a lot of weight in the box. And, you know, that box weight doesn't earn you any money. If you're flying freight, you want the lightest possible box. So, you know, the way we've configured Airlander 10 at the moment is it carries a pair of winches on a winch beam that can pick up 5 to 6 tons of freight, but we'd prefer it was loaded probably onto a standard aerospace pallet for transition onto the aircraft, so that you minimise the sort of parasitic weight of the box. But all things are possible, and certainly as you go to Airlander 50 and Airlander 200, those options potentially become available to us.
Thanks for that one. Being a man who lives in Slough, this is the Heathrow branch. It's Jerry Anderson all over again. We're about, I live about two and a bit miles away from Jerry Anderson's studio. I've never thought of it before, but doesn't Airlander look a bit like Thunderbird 2 as a lifting body?
I'm afraid so. Yes, we do. We do get tarred with that one quite often. I kind of prefer the white of Airlander to the green of Thunderbird 2, though.
Oh, I like the Green Thunderbird too. I've got another question that's mine and not from the list at the moment. And just thinking about that, your aeroplane used to be called the Bum, and I'm looking at the back of your aeroplane, and it's less bum looking these days. You've got those cottage fairings at the back to make the boundary layer attached there. Was that deliberate?
Well, of course, remember that I think it was the Daily Mail, other newspapers picked up on it, but I think it was the Daily Mail that coined the flying bum phase. And that was about the front of the aircraft, as best I understand, because there was a cleft between the two front hulls. The work we've been doing with MGP at Silverstone, we've cleaned up that front shape and it no longer has that cleft. So I'm rather hoping that we've left the bum piece behind us. But to be brutally honest, people will always find nicknames and things for aeroplanes. It's fairly low down my list of worries. I'd like aerodynamic efficiency ahead of a nickname.
Yeah, I'm sorry about that. I just couldn't resist it.
Yeah, thanks, Lisa.
Okay, being an ex-Air Force person, question here. What new maintenance challenges do you foresee for the Airlander series? What would be the airframe life? What about times between overhaul, etc., etc., etc.?
Now, there's a big subject. So for the prototype aircraft, I think the longest we spent out of the hangar on the mast was about 6 months. And throughout that period, obviously, we had routine maintenance we had to do. And the team developed the techniques necessary to be able to maintain the aircraft outside of a hangar. And that included doing things like oil changes, filter changes, and replacing the odd actuator that failed and all those sorts of things, as well as the standards of hull inspection and structural inspection and so forth that we were putting in place because we were a new aircraft in prototype flying. So my production team did a stellar job of developing the how do you gain access to everywhere on the aircraft while it's outdoors. You know, we're an OEM. We don't want to be a business that has to sell a hangar with every single aircraft we sell. You know, our whole plot is take this aircraft away, use it for a year. You can do your yearly check out on the mast if you want to, but you can do it slightly quicker if you bring it back to a hangar and do it indoors. But it is perfectly possible for one of our aircraft to go outdoors and stay outdoors for years on end. We're looking at we have all the standard maintenance cycle type stuff you would expect, A, B, and C checks and so forth. We're looking currently we oil change and filter change at about 240 hours, and that's really driven by the current design standard of the engine and the systems around it. We're looking at the potential for extending that as well. But in terms of the life of the aircraft, we do all of our sort of business case and cost analysis on the basis that the aircraft will live for 20 years. And the only big piece of maintenance stroke swap out that we do is our current plan is every 10 years you swap the hull out. Now that sounds like quite a major task to do, but actually the hull is a reasonably straightforward piece of equipment to swap out. You're in the hangar probably for 6 to 8 weeks to do a hull swap. We've done them in the past on smaller products. And the reason you swap the hull out is simply you design the hull to be able to cope with the material degradation you get due to UV from being outdoors all the time. And there's a trade there between the thickness of films to protect against UV and the weight and so forth. So in our sort of worst UV environment, say somewhere down in the Gulf, we should get 10 years out of the hull. Somewhere in the UK, the UV level is lower, probably 12 to 14 years. But at the moment, all our costing is done on a 10-year swap out.
Given the size of the Airlander, how will it impact activity in highly developed urban city centres, i.e. for freight operations? You mentioned it can hover on empty fields around distribution centres, etc. Will this still be the case in the near future? Will that land still be available?
So I think the freight delivery thing, I don't see our aircraft hovering a couple of 100 feet above the centre of London anytime soon. I think we're much more focused on the distribution centres. They're here to stay. And I look at the real estate space that they take up on the ground. I mean, some of these buildings are acres and acres of surface area. I'm completely comfortable we can operate over the top of a building like that and deliver effectively in through the roof if that's what we needed to do. I agree. I agree with the questioner that eventually the greenfield sites will be developed out, but our ability to deliver from the hover, I think, is perfectly doable. At least main hub to main hub. Alternatively, let's put it down on water and move it to the bank on a boat.
Okay, moving on. There are several different questions that I'll try to put all into one, and that's around meteorology. Compared to current fixed-wing aircraft, how is the Airlander affected by prevailing winds? Are there particular weather situations that you see as not good for your aircraft? Will these have a dramatic effect on the range and journey times? And the questions go on. I see you call the aircraft IFR certified at the end of the day. Quick answer on that one.
So fundamentally, we're designing the aircraft for takeoff and landing in winds up to 35 knots. And that's a reasonable level of wind. We can look back into the 50s and 60s where the US Navy was operating large lighter than air platforms out in the Atlantic and they were providing 24/7 barrier protection for months on end, flying aircraft in and out of that pattern. Yes, there is an impact to the aircraft in terms of flying into headwind. We're flying 120, 130 kilometers an hour. A 40 knot headwind is going to, a 40 kilometer hour headwind is going to have an effect on the time it takes you to get to your destination for the short haul stuff. When you get to longer haul, when you want to go fly 1,000 nautical miles or something, then actually you tend to be able to fly weather patterns. And all the analysis we've done on weather pattern flying shows you can actually make a benefit to your flight time by flying in a non-straight route. You fly with the wind behind you. We don't take advantage of that in our analysis. We tend to go with zero wind condition. But we spend a lot of time with our performance models analysing how we deal with wind and the impact it has on service provision and so forth.
Okay, last question. Again, I'm looking down and I'm going to put 3 or 4 questions together. Who do you see as your airship competitors? Stop. On the mobility side, who do you see as your competitors? Aircraft trains, air taxis, etc., the Lilium type aeroplane, etc. Again, who are your competitors? So
I don't believe we compete with the eVTOL market, and our Airlander is designed around a sort of 90-seat capacity, so it's more of a domestic bulk travel product as opposed to the 10 to 20 seat end of the marketplace. We think so. We don't think we've got too much competition between our two areas for that. As to what we compete with, I think it depends on which market you're looking at. I mean, we've done study work out in the Far East where we're predominantly competing with ferries, and the ferry has to go all the way around their islands, and we can go straight over the top. Do we compete with airplanes? I think on some routes we might well be able to, but I think it's all got to be set now in the context of sorting out this carbon production issue that aviation is badged with, and we see that we've got that part to play in that, and we don't want to predicate where our sweet spot is. We know what our aircraft does, we know its capability, and we think we're getting our message across to the various customers and potential customers that we're looking at out there.
Okay. Well, for those of you who have set questions that I've not managed to cover, I do apologise. I think most of the questions I've combined with other people's questions. Anything with a multiple thumbs up I've covered. So let's draw the questions to an end and draw the whole session to an end. Mike, on behalf of the committee and the members of the Heathrow branch, I must thank you. Your valuable time was very valuable to me. I really enjoyed that. You could tell the questions overran by much longer than we agreed yesterday. I couldn't stop asking you those questions. They're all things that were going on in my head anyway, so I took a full advantage. Thanks ever so much. I'm going to thank you, as I say, and wish Hybrid Air Vehicles and yourself the greatest technical and commercial success. Thank you. I'm going to say no more, that's it. William, quickly, thank you as our Honorary Secretary. You made this thing possible. You administered the day, you administered the plans and the progression of today's meeting. Thank you very much indeed. I'm going to thank all of you that sat and listened today, all of our members and the guests. I hope that you've all learned as much as I have. I'm unable at the moment to give you a date for your diary concerning the next branch lecture and webinar, the January lecture, nor can I give you an exact title, as William tells me that he's not got the details sufficiently firmed up to go live today. So watch out for the calling notice from William in an email. Look out for the branch event web pages, look out for the main society's web pages, and look out for the social media posts, and get your seats booked for the next one. It's going to be a good one. I think it might be a two-man Mutt and Jeff session. Finally, I'm going to look forward to seeing you all again very soon. I wish you all great health, good luck for the rest of the year, and a very happy Christmas holiday. I wish you success 2021.
From across the globe, from the centre of aerospace, and now to you.
Thank you for downloading from the Royal Aeronautical Society. If you enjoyed this content, please consider showing your support for the Society. Share a link to this presentation by email or on your favourite social networks. If you have an interest in aerospace, consider the professional and personal benefits of membership. Visit www.aerosociety.com.